Hello students, welcome back to our class. Now in this module we are going to discuss about long answer type problems from the very first chapter, that is real number system. So in this chapter one question is compulsory in your board examination, and I have compiled a few set of problems which were given frequently in board examinations. So see how I am going to solve and what is the strategy behind using the problems, because these are compulsory problems in your coming board examination. So the very first problem is here, that prove that root 3 is irrational number. How do you prove that root 3 is irrational number? Generally we know that root 3 is irrational number, but how to prove that root 3 is irrational number, we do not know. Suppose if you think of dividing this number or trying to find the square root of this number by long division method or by dot method or by bar method, any of the method, then you keep getting digits after the decimal, and you will understand after some certain number of digits, after 5 digits or 6 digits or 10 digits, so there is no pattern is repeated. So then can we conclude that this is a decimal expansion which is neither a terminating nor recurring decimal? No, we cannot say that, because maybe after 11th digit the digits may be repeated, or after 12th digit the digit may be repeated, so that there is no particular way of proving that, there is no technical way of proving that it is irrational number by that division method. That is just a generalization, that's it. So by the generalization we cannot say that this is the proof. So then we will have to think logically about proving root 3 is irrational number. So in order to prove this root 3 is irrational number, I would like to introduce you one different method which is called indirect method of proof. So in our mathematics there are two types of proofs in order to prove any mathematical statement. One is direct method of proof and second one is indirect method of proof. So what is direct method and what is indirect method of proof? So in this direct method of proof, generally in even grade 9 and grade 10, we proved some statements like, for example, in a right angle triangle, the square of hypotenuse is equal to sum of squares of other two sides. So that is one mathematical statement. We will see what is given in information in the statement and what are you going to prove. So the given information is nothing but the triangle is right angle triangle, in which one of the angle is 90 degrees. That is the information given. Through some logical sequence of steps, we may end up with the conclusion. So what is the conclusion? Hypotenuse square equal to side square plus side square. That is what called direct method of proof. But what is indirect method of proof? So this indirect method of proof can be used in order to prove this kind of statements. Because here there is no particular way of proving this. Then we go with indirect method of proof. What is that indirect method of proof? Let us assume that our statement is wrong. So what is the statement here? Root 3 is irrational number. So let us assume that root 3 is not irrational number. If it is not irrational, then it is a rational number. Then through some logical sequence of steps, we end up with a wrong conclusion. That is what called contradiction. We may arrive at a contradiction. Contradiction is nothing but getting a wrong result. Why are you getting wrong result? Because of your wrong assumption. So you have assumed that root 3 is irrational. That is not, you have taken that assuming that root 3 is not irrational. Root 3 is not irrational, that was wrong, right? That was the wrong assumption. So that is why you are arriving at a contradiction. So by that you can say that our assumption is wrong. So therefore root 3 is an irrational number. That is what is the proof of the statement which is called indirect method of proof. So I will explain you by this problem what is indirect method of proof and how do you prove this kind of statements by using indirect method of proof. Okay, so coming to the statement here, by indirect method of proof, let us assume that root 3 is not irrational. Assume that root 3 is not irrational. So if root 3 is not irrational, then what it is? Then it is a rational number. So then root 3 is rational. And we know by the definition of rational number, every rational number can be expressed in the form of p by q. So then root 3 is equal to some p divided by q, where of course q is not equal to 0. P comma q are integers. And the very important thing here is HCF of p comma q is equal to 1. Bracket p comma q is nothing but HCF of p comma q is equal to 1. It means both numerator and denominator should be in simplest form. Right. So this point plays a key role here in proving this statement. Okay. So root 3 is equal to p divided by q. By cross multiplication, you can say that p is equal to root 3q. P is equal to root 3q. So then by squaring on both the sides, we can write it as p square is equal to 3q square. P square equal to 3q square. Now, p square is a square number, is equal to 3 into something. So, p square is a multiple of 3. So, tell me one number which is a square number and also which is a multiple of 3. What is a square number which is a multiple of 3? Can I take 81? So 81 is a square number because you can write 81 as 9 square, and 81 can be written as 3 into something, whatever that something is. Correct? So here 81 is a multiple of 3 because 81 is also a square number. So 81 is a multiple of 3. Then what is square root 81? Square root 81 is equal to 9, can also be written as 3 into something, right? So if 81 is a multiple of 3, then square root 81 is also a multiple of 3. Got my point? See here, p square is a square number which is a multiple of 3. If p square is a multiple of 3, then what about p? 81 is a multiple of 3, then square root 81 is equal to 9 is also a multiple of 3. Therefore, since p square is a multiple, p square is a multiple of 3, then p would also be a multiple of 3. P would also be a multiple of 3. Then how do you write that p? Since p is a multiple of 3, let p is equal to some 3 into m. So where m is any positive integer. Okay? Because p is a multiple of 3. Let me take this equation as first equation. Now I am going to substitute p is equal to 3m in first equation. Then first equation will become p square is equal to 3q square. Then p is nothing but 3m. So 3m whole square is equal to 3q square. So 3m whole square is going to be 3 square is equal to 9m square is equal to 3q square. Correct? So 9m square is equal to 3q square. 3 1s and 3 3s are gets cancelled. Then finally what do you get? 3m square is equal to q square. See, this one also similar to the first equation, right? So then here q square is equal to 3m square. Correct? Since q square is equal to 3m square. What is meant by q square is equal to 3m square? Similar to this, p square is equal to 3q square, where p square is equal to 3q square means p is a multiple of 3, p square is a multiple of 3. So here q square is equal to 3m square means q square is a multiple of 3. Q square is a multiple of 3. Then q would also be a multiple of 3, right? Q also a multiple of 3. Since q is a multiple of 3, can I take q is equal to some 3 into n, where n being any positive integer, right? So q can be expressed, q can also be expressed as 3 into something. P is equal to 3 into something, q is equal to 3 into something. Now I am going to consider p divided by q. What is p here? P is equal to 3m divided by q is equal to 3n. So 3m divided by 3n. What is 3m divided by 3n? You don't cancel here 3 and 3 there. Why? Because p divided by q where HCF of P comma Q is equal to 1. But what is HCF of P comma Q here you are getting? HCF of P comma Q is equal to HCF of 3m comma 3n. So HCF of 3m comma 3n is going to be 3, but it is not equal to 1. Did you get my point? Here you have considered that HCF of P comma Q is equal to 1, but you are not getting HCF of P comma Q is equal to 1 here. Getting HCF of P comma Q is equal to 3. This is what is called wrong result. That is what is called contradiction. We arrived at a contradiction. So here HCF of P comma Q is equal to 3 but not equal to 1. This is a contradiction. What do you call that? This is a contradiction. Contradiction is nothing but getting wrong result is a contradiction. This is a contradiction. Therefore, our assumption is wrong. Therefore, our assumption is wrong. So, since our assumption is wrong, then what is right? Therefore, root 3 is irrational. Therefore, root 3 is irrational. This is what is the proof, is called indirect method of proof. And here, what is the advantage of this proof? If you want to prove root 3 is irrational number, this is the proof. If you want to prove root 2 is irrational number, this is only the proof. In the place of 3, you can write 2 simply. Every single step is same as like root 3 is irrational number, root 2 is irrational number, root 5 is irrational number, root 7 is irrational number. So finally, root P is irrational number where P being a prime number. So P being a prime number, then this is only the procedure. In order to prove root P is irrational number, P is being a prime number, can be any prime number. So please be focused, and this is a compulsory problem in your board examination. Either this problem, otherwise the similar kind of problem that we are going to discuss now. So those problems, including the square roots only. So please be focused on the way that I used in order to solve this, in order to prove this root 3 irrational number, root P irrational number, root 5 irrational number. Right? Coming to the next problem. Here it is, prove that 3 plus root 5 is irrational number. 3 plus root 5 is irrational number. We can answer this problem in two ways. Those two ways are, first you prove that root 5 is irrational number by the indirect method of proof that we already discussed in the previous problem. After proving that root 5 is irrational number, since 3 is being a rational number and root 5 is irrational number, therefore sum of a rational and irrational becomes an irrational number. Therefore 3 plus root 5 is an irrational number. So after proving root 5 with the help of 3 more steps, we can conclude this problem. That is one way. And the other way suggested in the textbook is, let us consider again by indirect method of proof. So let us assume that 3 plus root 5 is, let us assume that 3 plus root 5 is an irrational number. It was irrational number, right? 3 plus root 5 is a rational number, because that is our assumption, right? Let us assume that 3 plus root 5 is a rational number. Is a rational number. So since it is a rational number, as same like previous problem, assume that 3 plus root 5 is rational, then 3 plus root 5 is equal to P divided by Q, right? Of course, where Q is not equal to 0, P comma Q are integers, and HCF of P comma Q is equal to 1. HCF of P comma Q is equal to 1. Now 3 plus root 5 is equal to P by Q. What do we do here? We'll transpose this 3 that side. We'll transpose the 3 this side. Then it would be root 5 is equal to P divided by Q minus 3. Then you can write it as P minus 3Q divided by Q. So finally what do you get? Root 5 is equal to P minus 3Q divided by Q. Now observe here, root 5 is clearly an irrational number, and P is a rational number, Q is a rational number. That implies P minus 3Q, P is an integer basically, right? So P is an integer, you can take it as an integer, because we'll have to follow the definition. P is an integer and q is also an integer, then p minus 3q obviously an integer. So then p minus 3q divided by q is obviously a rational number, because integer by integer gives a rational number. So what did you get here? An irrational number is equal to rational number, because root 5 is irrational and p minus 3q by q is rational. So here we got irrational number is equal to rational number. Irrational number is equal to rational number. So is this correct? There is no such number which is both irrational as well as rational number. So this is a contradiction. This is a contradiction. So why did you get this contradiction? This contradiction is only due to our assumption, right? So what was our assumption? 3 plus root 5 is a rational number. That was our assumption. So therefore 3 plus root 5 is not irrational. 3 plus root 5 is not irrational. Then therefore what it is not rational, sorry. 3 plus root 5 is not rational. Since it is not rational number, then it is an irrational number. Therefore 3 plus root 5 is an irrational number. Is an irrational number. So this is the way of proving the problem. This is another way of proving the problem. I already suggested one more way, that you prove that root 5 is irrational by our indirect method of proof. And then conclusion is, since 3 is being a rational and root 5 is irrational, rational plus irrational is always irrational. That is one proof. And this is one more proof. Right? Next. Another type of problem here is, prove that root 3 plus root 7 is irrational. Now there are two numbers which are irrational. See, there is one more easiest way that I am going to suggest to you, that again by indirect method of proof, let us assume that root 3 plus root 7, let us assume that root 3 plus root 7 is not irrational. Is not irrational. If it is not irrational, then it is a rational number. So then root 3 plus root 7 is a rational number. Is a rational number. Since it is being a rational number, then we can express this one as p divided by q. So that implies root 3 plus root 7 is equal to p upon q. So I cannot transpose one number that side, because again that is irrational number. So I would do one thing, that I will square it on both the sides. So by squaring on both the sides, we get root 3 plus root 7 whole square is equal to p divided by q whole square. So what is root 3 plus root 7 whole square? Root 3 whole square is equal to 3. Root 7 whole square equal to 7. Plus 2 into root 3 into root 7 is equal to 3 7s are 21, is equal to p by q whole square is p square by q square. Right? So 3 plus 7 is equal to 10. 10 plus 2 root 21 is equal to p square by q square. Now transpose 10 towards right hand side. Then it would be 2 into root over 21 is equal to p square by q square minus 10 by 1, which is equal to p square minus 10q square divided by q square. This is what? 21 into root 2. Sorry, 2 into root 21. So then we can write it as root 21 is equal to, now transpose to that side. Then it would be p square minus 10q square divided by, when you transpose 2 also that side, 2 into q square is equal to 2q square. Now you observe here, root 21 is purely an irrational number. P is a integer, p square obviously an integer, q is an integer, q square and 10q square also integer. So integer minus integer is an integer divided by an integer. So integer by integer is a rational number. So here it is a rational number. Now what did you get here? An irrational number is equal to rational number. An irrational number is equal to rational number. So irrational number equal to rational number means, what is your conclusion? an irrational number is equal to a rational number. So this is absolutely wrong. So this is a contradiction. What it is? This is a contradiction. So this contradiction is only due to our assumption. So therefore our assumption is wrong. Our assumption is wrong. So what is correct then? Therefore root 3 plus root 5 is irrational. Therefore root 3 plus root 5 is irrational. This is what is correct. So hope you understand how to prove first root 3 irrational number, 3 plus root 5 irrational number, root 3 plus root 7 irrational number. So these three problems are can be solved in three different ways. Please be focused on all these three types of proofs, because this problem is 99.99% compulsory in your board examination, so that you will definitely get full marks if you follow this procedure, right? Let's move on to the next problem. So the next problem is find the HCF of 32 and 54 using division algorithm. What is division algorithm? Basically division algorithm is nothing but division rule. Okay, so division algorithm is a division rule. That is what A is equal to BQ plus R, where 0 less than or equal to R less than B. It means here A is the dividend, B is the divisor, Q is the quotient, R is the remainder. So the value of the remainder is always lie between 0 and the divisor. It can be 0 but it cannot be the divisor, that's why less than the divisor. This is what is division rule or division algorithm or division lemma also. You can call it as a division lemma. So now, how do you find out the HCF of these two numbers by using division rule? So first of all, try to find out the HCF of those two numbers by long division method or short division, whatever that is called. Okay, so I am going to divide 54 by 32. Okay, I think you know the procedure of finding HCF by this division method. So 32 ones are 32, because 32 twos are 64, it is more than 54. Now subtract 4 minus 2 equal to 2, 5 minus 3 is equal to 2. Now this remainder is the divisor is the dividend, right? So 22 ones are 22, and now 2 minus 2 equal to 0, 3 minus 2 equal to 1. Now this remainder is the divisor, this divisor is the dividend, right? So 10 twos are 20, remaining 2, and then this is 10, so 2 5s are 10. Finally you get the remainder 0. So for which division you get the remainder 0, that divisor is said to be the HCF of the numbers. Hope you understand. So HCF of 32 and 54 is going to be 2. 2 is the HCF of those two numbers. Now how do you write them in division algorithm form? Please do remember how many number of divisions have been performed. So the very first division here performed is, see, this is what is the first division that is performed here. Correct? This is the first division. I am going to write that first division in division algorithm form. Dividend is equal to divisor into quotient plus remainder. Clear? So dividend is equal to means 54 is equal to divisor into quotient plus remainder, that is 22. And what is the second division performed here? This is what is the second division. Okay, so again write that second division in division algorithm form. What it is? 32 is equal to 22 into 1 plus 10. 22 into 1 plus 10, that is second division. And coming to third division, this is what is third division, that is 22 is equal to 10 into 2 plus 2. 10 into 2 plus 2, that is the third division. And what is the last division here? This is what is the last division, that is 10 is equal to 2 times 5 plus 0, right? So in fact you will have to write these steps without using this, but if you use this, then it would be easier for you to write every single division in division algorithm form, right? So here in the last division you get 2 as the divisor, therefore HCF of 32 and 54 is 2. This is what is the way of finding HCF of the given two numbers by division algorithm or by using Euclid's division lemma. The another name of that division algorithm is Euclid division lemma. So please do remember the procedure, and this is what is the first thing that has been performed, and then easily you can write every single step, right? Good. Next, coming to the next problem. The length, breadth and height of a hall are 8 meters 25 centimeters, 6 meters 75 centimeters, 4 meters 50 centimeters respectively. Determine the longest rope which can measure all the 3 dimensions of the hall exactly. What do you mean by that? See, for example, the length of this board is equal to some 10 meters, and breadth of the board is equal to some 8 meters. Length of the board is 10 meters, breadth of the board is equal to 8 meters. Now I have a scale, right? So that scale measurement is maybe 30 centimeters or 20 centimeters or 30 meters, 20 meters, whatever it is. So I need to measure this length as well as breadth exactly. Exactly in the sense what? See, I will have to divide this length into exact measurements and breadth also into exact measurements. Otherwise, if you have a stick, for example, you have a stick. This is one stick. Okay, and this is one more stick. These two are two sticks. The length of this stick is equal to some 20 centimeters, and length of this stick is equal to some 8 centimeters. Okay. Now I will have to use one measurement, that I will have to divide, or I will have to cut this 20 meter stick as well as 8 centimeter stick into exact measurements. So into exact measurements means how can I measure that? Exact measurements means I will cut this into 5 pieces, for example. Now the length of one piece is equal to 4 centimeters. Then I will have to cut this into two pieces, each one is equal to 4 centimeters. Suppose if I cut this into 2 centimeters, right? So 2 centimeters and 4 centimeters gives the same length there, but 4 centimeters will give the maximum length. Like that, what is that 4 centimeters to 20 and 80, 20 and 8? That is going to be the HCF of the numbers. So you need to find what is the HCF of these measurements. There ends the matter. You understand? So in order to find HCF of the given numbers, you understand one thing, that they are in meters as well as centimeters. Convert them into same units, either completely in meters or completely in centimeters. But converting them into meters maybe gives decimals. Then it is not that easier to find HCF of those numbers. So that is why convert them into centimeters, then you will not get decimal. So you can easily find out what is HCF of the numbers. So the given measurements are going to be length, breadth and height of a hall. So length of hall is equal to, what is length of hall? 8 meters 25 centimeters. Now converting centimeters is I think more easier than meters, which is not useful at all. So 8 meters is equal to how many centimeters? 1 meter equal to 100 centimeters. 8 meters is equal to 800 centimeters plus 25 centimeters. What is 800 plus 25? 825 centimeters. That is what is the length of the hall. And what is breadth of the hall? Breadth of the hall is going to be 6 meters 75 centimeters. 6 meters 75 centimeters. 6 meters means again 600 centimeters plus 75 centimeters. So 600 plus 75 is going to be 675 centimeters is the breadth of the hall. And what about the height? Height of the hall. So height of the hall is going to be 4 meters 50 centimeters. 4 meters 50 centimeters. What is 4 meters here? 400 centimeters plus 50 centimeters. 400 centimeters plus 50 centimeters is going to be 450 centimeters. Now I have those three measurements in centimeters without decimal. I am going to find HCF of those three numbers by prime factorization method. Okay, so the first number is 825 and the second number is 675 and the third number is 450. I am going to find the factors, right? First of all, I would like to factorize this by 5. So 5 times 5 ones are 5, 32, 5 6 are 30, 25, 5 5s are 25. Again it can be cancelled by 5. So 5 into 5 3s are 15 and 5 3s are 15. Again 5 multiplied by 5 multiplied by 3 multiplied by 11. Now this is what is the prime factorization for 825. Coming to 675, 5 times, again 5 ones are 5, 17, 5 3s are 15, 25, 5 5s are 25. Again 5 into 5 2s are 10, 5 7s are 35. Again 5 into 27 is going to be 9 3s are 27 or 3 cube, that is 3 into 3 into 3. This is about prime factorization of 675 and 450. That is 5 times 5 9s are 45 and 0 is there now, 5 90s are. And again 5 times, 5 ones are 5, 5 8s are 40. So now it is 5 into 2 into 980, 9 is 3 times 3. So this is what is the prime factorization of 450. Now there are three prime factorizations of numbers. Okay, so the first number is 825 and what is the second number? Second number is 675 centimeters whatever and 450. Let us pick up the common factors from all the three numbers. See here, 5 is available, 5 is available, 5 is available. Therefore, HCF of those three numbers, what are those three numbers here? 825, comma 675, comma 450, which is equal to first 555, so 5 is the number, and then you can find out one more 5 here, so 5 and 5 and 5, so one more 5 is the common factor, and then 3 is here, 3 is here, 3 is here, so you can take one more 3 here and one more 3 here and one more 3 here. Is there any other number which is the common factor? 11 is here but 11 is not there. So therefore 5 into 3 is only the common factor for all the three numbers, that is 5 5s are 25, 3s are 75 centimeters. Therefore what is the longest rope? Therefore the required longest rope, which is equal to 75 centimeters. This is what is the way of answering the problem. See, if you can take 3 centimeters long rope, with that 3 centimeters long rope also we can measure all the three dimensions. If you can take 5 meters long rope, then with that also we can measure all of them. If you take 5 into 3 is equal to 15 meters long rope, with that also we can measure all the three. 5 into 5 is equal to with 25 meters long rope also we can measure all of them. But what are you asked? You are asked the longest rope. So the longest rope should be the HCF, highest common factor of the given three numbers. And this is the way of solving the problem. You understand? So we discussed about long answer type problems in this module. So please be focused on every single problem and the strategy, the way that I solved every single problem on the board. Then you can easily score very good marks according to your SSC board examination point of view and marking scheme also. So hope you understand, enjoy the class. Thank you.